All right, so today we have our monthly newsy roundup with my friend Paco Newton, founder of Derwin, but now also a principal developer relations engineer at Sensing, where he works at the intersection of, I guess, NLP, Graph AI, and Graph Intelligence. So, Paco, welcome back to the podcast.
Thank you very much, Ben.
All right, so I think generally I've been starting this monthly news roundup with a roundup of LLM news focused on releases. So last month I deviated, I kind of focused on LLM interfaces with Claude artifacts. This time I'm also going to deviate a little bit because I think this is super important for us who are following LLMs and using them in foundation models. So I guess the big release this month is probably Llama 3.1, which has a 400 plus billion version, and I've been using it. It's great. I think it's fair to say it's not open source. So I know that Mark Zuckerberg likes to use the word phrase open source, but probably open weight is more accurate. So I recommend people talk about it that way, so that it doesn't kind of confuse people about what it truly is. So there's that development, and then the second development in this space is uh, the tech publication, the information published an article about OpenAI, where I believe they got a hold of OpenAI's some of the financial projections, and it's not good, right? So the company has raised
Yep.
11.3 billion. At the last round, the valuation was 80 billion. Revenue this year may be in the order of 3.5 to 4.5 billion. But the cost of operating these models is about 4 billion a year. So just because we're using these models doesn't mean it's free to operate it, right? So that's the cost of operating. So then there's also the cost of actually training the models, right? So which may run them at 3 billion a year. And then the workforce expenses is about 1.5 billion. So long story short, there might be a shortfall of around 5 billion this year, which puts pressure on the company to either figure out, product market fit or raise another round of money, right? Because the cost of training these models, the models are getting bigger. So,
Yeah.
so there's just, so set aside, let's say the cost of training the models remains the same. Well, based on what I just told you, there's financial sustainability challenges, right? But throw in the fact that the models may get more expensive to train. So now you have escalating training costs. And then to top it off, I just told you that Meta Llama 3.1 got released. So then now you have the problem of differentiation. So what exactly is your differentiation? Assuming your model is better, is it substantially better that people will actually gravitate towards you? So then now you have differentiation. Now you also have to figure out your product market fit. So maybe serving models through an API is actually not the way to go. Maybe you come up with a different product. I don't know what that is, search, or I'm just imagining,
Yeah.
right? But that doesn't exist. You have to figure that out. So that's the baseline. Now you have the external challenges, right? So you have regulatory headwinds. You
Yeah.
have data acquisition and legal issues because now you have to license data from the Financial Times, the Economist, and all these people, right? New York Times. I mean, they've wisened up. They're not going to give away their data so that you can just scrape it for free. Energy consumption. Um, and then
Yep.
finally, on the enterprise side, and this is something that Paco and I discussed last time, is there's still a bit of misalignment between hype and actual ROI and reality. So right now, enterprises are a bit of in the FOMO phase, fear of missing out. So they're investing. So in other words, so there's challenges. So Paco, I'm not done. There's another piece of news. There's
Oh,
another
yeah.
piece of news which is basically character AI, which is a fairly successful startup founded by some of the really uh, great innovators in terms of actually building LLMs, right? So uh, Noam Shashir and Daniel DeFreitas, they're going back to Google, right? So
Oh,
the reason I bring them up is now you're looking at a company that's actually quite successful on the consumer side, which is basically, you build these characters, you can chat with them, and then you pay them a monthly subscription. But their whole thing was they're building their own LLMs for this purpose. So what does this mean? So I think Noam and Daniel are going back to Google because they want to focus on building AGI and building, pushing the models even further. So to me, this signals maybe this and character itself. By the way, in as part of the announcement that Noam and Daniel are heading back to Google, they said, "Well, look, we're getting out of the business of training our own LLMs. We're just going to rely on external LLMs and and use them as part of our product." Right? So this signals that this whole business of training your own LLM is might not be sustainable, right? So I mean, I just laid out the financial picture for OpenAI. I'm sure Anthropic is the same picture, maybe slightly worse because maybe the revenue is worse, right? So I'm sure they have the same personnel costs, roughly, right? So same kind of operational costs in terms of inference. Yeah, so then there's a lot of challenges here. So I've written a couple of posts. So the first one, I guess the main one I recommend you to is the shifting landscape of large language models, which I will link to in the episode notes. But for those of us who are excited about this technology and wanted to thrive, obviously this is a bit of a worrisome news, right? Because basically and I've been talking about this in our monthly conversations, Paco, the fact that we
absolutely.
we
Yeah.
need diversification in terms of model suppliers. And
Yeah.
now, it's great that Meta is committed, but Meta is Meta. We don't know what they're going to do down the road. I mean, we've been down the road with Meta before
Right.
on other things, right? So, and then Google is doing Gemini, but Gemini is not open. It's not an open weights model, right? So, I guess OpenAI and Anthropic are not, but basically, it's a bit of a worrisome situation for us. And to me personally, I'm not one of these people that want these high flying startups to fail. I mean, I want them to succeed because basically, uh, they're they're good kind of uh, signs that things are moving in the right direction. But we need to figure this out. We need to figure out how to do this in a sustainable way. So that's my rant. Let's dive deep. This is an important topic, right? So
Yeah, I mean, what are the implications on research, right? I mean, it would be ideal if a lot of universities around the world could really focus on research and publishing but are they, I mean, effectively either you align with one of the big tech companies or you're kind of locked out. I mean, good luck getting enough money to be able
yeah,
to do the
because
training.
you have so the universities are basically outgunned, right? Because you've
Yeah.
got to have big data. They don't have big compute. They don't have, right? So
Yeah.
and then to actually test and run the big models, you need skilled engineers to build the infrastructure, distributed systems, ray clusters, and all of this. And I don't, outside of Berkeley and maybe a few other universities, Stanford, there's not a lot of people that can do that, right? Uh,
Yeah.
so then now you go. I guess the Europeans may try to have their own kind of European champions as far as startups, but those startups will have the same headwinds that the American startups have, which is basically models are getting more expensive to train and operate. I have these personnel costs,
Yeah.
right? So I
Which are
don't have,
probably going up.
yeah, yeah, and then differentiation. What's my
Yeah.
differentiation? If there's Meta Llama 3.1 now, but there will be a Meta Llama 4 as right around the same time the GPT-5 is going to come out, right? Yeah, so there's a lot of I mean, clearly the for me personally, the technology is super useful for all the things I want to do, but I'm just a user. I'm not responsible for inference that's super cheap.
Yeah.
I mean, the inference cost is so cheap. It's essentially free to fine tune these models and not free. I mean, you're talking 30, 40, $50. You can fine tune a model and then you can use it to your but then if they raise the prices, I don't know. We're in a very tricky spot here. It's not like, so Paco, so for the youngsters listening to this podcast, I guess the situation during the dot-com era, right? So, I mean, the dot-com era, I mean, the early
Yeah.
startups were burning cash as well. Like Amazon was burning cash to sell
Yeah.
books online, right? But it seemed like and then at the early phases we thought that these folks are never going to make money. But in this case it seems like there's they have similar challenges but extra challenges in the fact that they have the compute just keeps getting more worse and worse. I
Yeah.
mean, so Amazon, I don't think had that problem. I mean, they just had to figure out the business model, right? So for selling books online or whatever, right? So
And selling compute.
yeah, yeah, yeah.
Um, well, what you're bringing up there, I mean, there's a lot of areas of this, but another aspect that I think is interesting to consider is the hardware side, because along with this kind of arms race amongst who are the different parties developing large models and how can we diversify that, along with that, there's also kind of an arms race of like AI chip wars and like the different hardware vendors actually spending a lot more money on the hardware but then trying to, get these windfalls of NVIDIA and others, I mean, making a lot of money off this space. And it strikes me that, the key to success in hardware that we've seen in this area is it's not just about the chips, it's also about the software stack on top of it and having
Mhm.
a full stack. And that's where NVIDIA has outgunned others and maybe, Intel has been struggling or trying to really build up. AMD appears to be doing really well in this area, et cetera. It strikes me, why aren't the hardware developers putting more money into diversifying the model building? Because they're actually the crucial component of it, but they're also the crucial benefactor.
Well, I mean, I think they are to the extent that Nvidia is selling to just about anyone who will pay them, right? So,
Yeah,
so I think a couple of things on that topic, right? One is that maybe AMD and some of these startups will start attracting more of the model training at some point. But I think it fundamentally still we're still in a situation where our I mean, our basic premise is scaling laws will continue to hold, right? So scaling laws for our listeners basically means your models get uh, more able, more capable, and more useful as you add more data, more compute. Uh, so that seems to be kind of the basic premise that we just keep growing and growing the data and the compute, and the models keep becoming more capable, right? So if you talk to the people building these models, that seems to be still kind of the basic premise. Now, unless someone comes up with a fundamentally different way of doing things that show that, hey, I can get good models without actually breaking the bank. I mean,
yeah,
so to some extent, I mean, people will say, well, aren't people doing that with compute limited applications like edge devices and stuff? True, but those are just they're more implementation in the sense that, someone pre-trains a model, maybe they distill and compress it and quantize it, and try to ship a good enough model on the edge, but it doesn't take away from the fact that the starting model that they began with is still built around this idea of, scaling laws, right? So we need to scale the models, because to get to AGI, we have to scale the model, right? So that's kind of the so at some point then we need nuclear fusion, right? So and we need a way to uh we need this, a business model, I guess, for people, right? So the other thing, actually, so with the character AI founders going to Google, right? So there's this, no, now we're looking at the acqui-hires seem to be also becoming a thing,
Mhm.
right? So large companies
Yeah.
are starting to acquire these startups for talent. Um, so which means obviously it's great for maybe the founders, but the employees who kind of went to these startups now are looking at, where are the founders? Without without founders, what's my equity, right? So the equity is not going to
Yeah.
be as attractive, right? So,
And,
um,
and and that spills over into VCs who've made big bets on these, et cetera. Yeah. Yeah.
yeah,
I still think,
the differentiation is not there yet, right? So I mean, so in other words, if you're OpenAI, yes, I love your model, but if you are not available for a week, I can survive because I have other options, right? So there's not enough differentiation for me to say that. In fact, honestly, so here's evidence, personal evidence on my part. I use all these models. I mean, I use Meta Llama, I use Anthropic Claude, I use
yeah,
Gemini, I use OpenAI on a regular basis, right? So I use all of
yeah.
them. So, and they all, I mean, I like all of them. Some models are good at other things. Other models are good at other things, right? But it's not clear to me that if I lose access to one model, I'm dead.
Like, I mean, the thing I'm questioning about economics is like Amazon subsidized business lines to be able to build up businesses. They did that and they took a really long-term view of it, and they did it really well. I think with AWS, they executed really well. I guess what I'm asking is, if you look at the combined annual spend on hardware development and also software stack development of, say, NVIDIA, Intel, AMD, maybe get Broadcom in there. If you look at how much they're spending per year, and you look at how much OpenAI and Anthropic might be going in the red per year. I mean, it's hugely disparate, right? I mean, the hardware vendors are spending billions and billions and billions,
Oh, yeah,
and it's a drop in the bucket.
they're
So
profitable
what
too, right? So I mean,
it,
they're
it,
booking profits at the expense of. So there's a couple of things here, Paco. So one is
huh,
on the subsidy side, right? Clearly, Meta, Google, and Microsoft
yeah,
can afford to subsidize, right? So in fact,
absolutely, yeah,
I think in the latest Microsoft earnings call, they admitted that their revenue from AI isn't that high yet, right? So considering the amount of money they've spent on it, right?
right.
But that's that class of companies. But then there's the other class of companies that we've come to respect in, like OpenAI and Anthropic, for example, maybe throw in Mistral. The startups that don't have the ability, they have to race round after round. I mean, OpenAI has already raised 11 plus billion, right? So now, if this information article is true, they're losing 5 billion this year. They're gonna have to raise more, right?
Yeah.
So, um,
Yeah, it was looking like this amazing success story. How could this ever stop? And now it's looking a lot more like a typical startup that maybe only has a certain amount of runway before they have to close, fold up.
so they need to
Um,
get to like some sort of product market fit. I don't know what that would be. I mean, I guess they're trying search, right? So, but then is there enough differentiation there? Whatever they're doing in search, there's no reason for me to think that Google can't do the same thing with
well, I
Gemini,
mean,
right?
I guess it also calls into question scaling laws because to me, okay, great, there's this academic argument about scaling laws, and that's nice, but there's also trade-offs, cost benefit trade-offs. So, it isn't just about how much data do you have, how large is your parameter space, your network, et cetera. It's also about like all the other things that go into it. Like you say, the personnel costs, the litigation costs, on and on and on, the regulatory controls. So maybe scaling laws have some other components that really haven't been taken into account there.
Well, I think so. The scaling laws are being driven by the fact that they are seeing. I mean, as you know, this field is highly empirical, right? So
Yeah.
they're seeing they continue to see evidence that as they scale, the models get more capable, right? So because the models keep getting better at these benchmarks, set aside the weaknesses of these benchmarks, right? In fact, you have this phenomenon now, benchmark saturation, where basically they're so good at the benchmarks, you need to invent new benchmarks, right?
Yeah. Yeah.
So that's the reason why. And also they're in this competitive race, right? So in other words, if you, Paco, decide, okay, scaling laws, I'm gonna deprioritize that. I'm gonna do something else, and then your competitors push forward on the scaling laws, and their models get better, right? So
Yeah, I'll flank you. Yeah.
yeah, it's just tough. So anyway, so that's my first item, which is a bit of a downer. I will come up with my second topic. Will try to recover the mood.
Okay, okay. I'll try to help too.
Yeah,
Well, and I'm going the other direction.
yeah.
I'm going to give a good one and then a bad one. So my first topic was there's a really great video out about neural operators. It's actually a TED Talk, but there's a paper on Archive. So this is coming out of Caltech. It's led by Professor Anima, a friend of ours, Anima and Nankumar. And their work on neural operators, the idea is using deep learning. One of the great things you can do with deep learning models is function approximation. So when you have really complex kinds of numerical approximation that are needed, hard engineering problems like building jet aircraft. Typically, you have these huge systems of partial differential equations, or you're doing Monte Carlo simulations, and there are similar problems elsewhere, whether you're talking about energy or hedge funds or whatever. And so what they found at Caltech has been some fairly encouraging news. It's not about LLMs, it is about deep learning. This field of neural operators, they're showing where they can get better numerical approximation of really complex systems
Oh yeah, this is
that
with
are
Andrew Stewart, I think. Yeah.
yeah, yeah, I think one of the authors. But it's entirely data driven. So for those of us who've done work with large systems of partial differential equations, it's very hard. I used to tutor that area. It's very hard work, and I think that this represents a really interesting avenue for R&D. A lot of implications on what can be done in enterprise because, enterprise, you do really complex what if calculations for contingency planning, whether you're in manufacturing or whether you're in transportation or finance. You're doing a lot of that number crunching. There's a whole lot of Monte Carlo analysis that goes on in finance, obviously. And so, can we get better at it? And the results coming out of Caltech are really interesting. 40,000x speed up in climate prediction models. So, like, if you're on the path of a hurricane, how accurate can you make projections about landfall and impact? Where do you evacuate people? Where do you deploy resources for emergency? And so they've increased the accuracy of climate prediction models, but also the speed. And so something that used to take hours might be taking seconds now. That has huge impact, especially if you live in a place like Florida. Also, healthcare, redesigned catheters for 100x reduction of infection rates, on and on. So I think this has broad impact on engineering in general, but especially for enterprise adoption of AI. And again, not about LLMs, but it is something that is sustainable and definitely has payoffs.
Interesting. Actually, I worked at PDEs. So I'm looking at this paper. So most of the ML techniques are universal approximators, right? So uh, I think even the kernel methods are universal. I mean, it's basically if you look at it's like the Stone-Weierstrass theorem in real analysis. They all converge to that when they're proving their universal approximator. So the question I have with this line of research is, um, to what extent does it beat the existing solvers that are not ML?
Yeah.
Like finite element methods and things like that. So it's interesting though. But this guy, Andrew Stewart, he's the real deal. Yeah. I know I'm friends. I'm good friends with his brother, who's also a mathematician. Who's also a PDE guy, but a theoretical PDE guy. But
Well, I'm just a pretend PE guy. I mean, I obviously you all did this for like dissertation work. I just like tutored people in math in this area,
yeah.
comparatively.
So I've been trying to figure out, you know, to what extent this is at that practical stage, right? So where they can really
Yeah,
solve complex nonlinear
yeah.
PDEs. They
To what ex
can. I think they
general.
can. The only question is the practicality, right? So
Yeah.
so
But I
that
mean, and the thing about solvers is that when you have an important area of technology, something that's like civilization changing, like how do you build airframes that are resilient? How do you build bridges that don't fall down? It usually comes back to solvers, right? There are these enormous solvers out on the market, and they're really expensive, and
right.
they're the heart of almost all engineering. And if we can apply deep learning to make improvements, they're great. I think the jury's out, but it's really encouraging to see this area, not just research, but also some R&D developments coming out of it.
Yeah, and then in this field, obviously, you need theory because basically you need to know
Yeah,
if the equation is going to blow up.
yeah,
You need to provide theory as to what will happen in those situations and so on and so forth. Very cool, very cool.
yeah.
All right, my next topic is a little more optimistic. I think I'll share a screen here. Let me see if I can. Um, Find, yeah. So basically, here the idea here is that it's a bit of counterintuitive in the sense that I mean there's so many tools for doing AI and generative AI and cloud services, open source projects, and so on and so forth. Is or open source projects available in the cloud who have cloud services, the cloud platforms themselves, right? So, but then I just started noticing why are so many of these so-called digital first companies that we associate with the tech sector, right? So, the Netflixes, the Spotify's, why are they building their own AI platform, right? So then what I did was I basically started watching talks, reading blog posts, and I
Hmm.
collected a list of reasons. And none of them are surprising. I'll just go through a few quick, but basically there are several reasons why they end up heading in that direction. And the idea here is generally, you know, I guess at some point, even though these companies are kind of digital first and they have robust engineering teams, um, they still have to justify why they're building their own platform, right? Internally and to their financial overlords inside the company. So are there
Sure.
lessons here for us?
Yeah.
So in other words, you know, if you have the chance to specify an AI platform to your unique needs and requirements, uh, would you do it? And why on earth would you go down this path, right? So, I mean, so some of the uh,
Mm.
reasons are, they have unique requirements, right? So, I mean, they might have very specific use cases or systems even that they need
Mhm.
to factor in, right? And then scale. Um, I mean, so yeah. Granted, this list of companies I have here are very sophisticated in terms of their engineering teams. Two Sigma is
Mhm.
reputedly
Absolutely.
basically
Yeah.
like a tech company, right?
Uh,
But
Spun out pandas. Yeah.
as Paco will be the first one to tell you because he's worked a lot in the industrial AI space that you don't have to be a tech company to have scale,
Yeah.
right?
Very
So
true. Very true.
so so you you might be surprised that some of these tools that you think you can just use out of the box may not actually meet your requirements, right? And then you might have some infrastructure that you really rely on that you need to kind of make sure that you are
Mm, yeah,
talking with your AI systems, right? So, and this is again, this is not unique. Maybe it's even worse with the non-digital first companies, right? Because
yeah,
the digital first companies, at least they kind of started, with modern tools off the bat, right? But some enterprises may have really hard integration problems with kind of these kind of uh, non-custom AI platforms. And then flexibility, you need to be able to basically innovate fast because, if you're in a competitive sector, which I'm assuming many of our listeners are, you don't want to be in a situation where you can't do certain things because the platform you chose has boxed you in, right? So that's one of the reasons that a lot of these companies cite, right? Um, and then surprisingly, this may surprise, and I think this probably is something Paco is very familiar with. That actually, once you start using some of these cloud services a lot, maybe you do a back of the envelope calculation that you realize, hey, if I buy my own servers,
yeah.
this is going to be cheaper to run. And I think a lot of companies, many companies are coming to this conclusion, right? Um, and then let's see what else. Yeah, obviously security compliance is a big issue, right? So certainly if you're in a regulated industry.
Yeah, absolutely.
And then there might be certain things that you don't like about the platform you chose. Maybe they're forcing you into a certain way of doing things or certain interface, right? So let's say your audience internally inside the company is mostly developers. Well, maybe developers don't want to use notebooks, right? So maybe they want to use IDEs. I don't know. So
Mhm.
there's reasons why some of these companies, there's reasons relating to productivity and workflows that these digital first companies have chosen, right? And then specialized data, right? So
Yeah.
for example, Uber needs a lot of geospatial data, right? And so on and so forth, right? So anyway, so it's just it's one of these things that I guess I went back to our roots, Paco, which is this notion of the alpha geeks, right? So the alpha geeks seem to be building their own custom AI platforms, you know, even in light of the fact that there's many platforms that you can just use and st- off the shelf, right? So obviously, some listeners might say, "Well, they're only doing that for talent retention and uh, and recruitment, right?" Well, you can do that to some extent, but I think that at some point,
Lots of money.
yeah, it's
Yeah.
gonna cost you money to. If that's your motivation to signal to the outside world that, hey, you can come work with us because you have cool projects, that's not going to cut it with your CFO or your business managers at some point. There has to be
Yeah.
a legitimate reason. So what I tried to do was I tried to understand, right? So we are all excited about AI. This digital first companies are excited about AI. Why are they decided to build their own custom AI platforms? That's it.
Well, this is super helpful, and there's a lot of key insights here, I think, very valuable for anybody working in this field, particularly the people who are in enterprise who are trying to get some guidance from, tech companies that are further down the path. I'm curious. I'd run by you kind of a high level, top level takeaways that reading through this that I had. I want to run by you. One is kind of uh, looking back in that a lot of these companies do have their own data ecosystems. They need particular data. They have particular customer data, provider endpoints, etc. And they need to customize for that for their internal processes. But the other one is looking forward. And I see them repeatedly saying, we're not sure how this is all going to unfold. The market is
Yeah. The
changing and
whole
evolving.
future proofing is
Yeah,
another reason that they
yeah,
give.
Yeah, those seem like the two top line things that I'm catching, and I think that both of those points would be even more a pain point, more salient pain points out in enterprise, more so than the tech companies.
Yeah, yeah, and that's why I think that I tried to, I didn't hide the fact that most of the examples I found were with these digital first companies,
Yeah.
but I tried to I guess what I'm trying to communicate is they may have there might be insights here that you as a
Yeah.
non-digital first company, a regular enterprise, may still learn from, right?
Well, I mean, that's a theme that you and I have been tracking together for like the past 7 or 8 years, where, yeah, we do see the tech leaders going in this direction. Some people are following, and others, they kind of need to understand that, or else they might be left behind.
Yeah, yeah, yeah. So anyway, so on to you.
Okay, great. The other one, maybe less of a positive note. So there was a vulnerability analysis that came out about LangChain. And there's a couple of Palo Alto networks published about the vulnerability. There's two CVEs regarding this. They're published through NIST. So basically, more than 1 billion builders use LangChain frameworks for LLM app development. Partner packages for LangChain include many of the big names and cloud AI databases and other developments. So potentially a lot of impact because of the breadth. And this is given, these CVEs, these vulnerabilities were given high and critical status, respectively. Basically, it's during the document loading part of LangChain, there's a vulnerability that allows arbitrary code execution and also access to sensitive data. So, this can have a lot of impact on maybe not attacking the models per se, but attacking the scaffolding, the infrastructure around deploying the models for applications. So this is something really to watch for. I think it's related to. I know you had Andrew Burt on recently on the Data Exchange on this podcast, talking about proactive strategies for effective AI incident management. And there were some key points there about being able to define the incident, detect them beyond just accuracy issues, understand like a comprehensive response plan, containment plans, etc. And I think this is a great case study in maybe where they could have had better response plan and containment plans, you know, ready to go uh, in advance before getting hit with a critical status CVE onto you.
By the way, this reminds me of another post I wrote recently, which is securing this software supply, AI software supply chain,
Yeah,
right? Because
yeah.
it's a known thing inside traditional software engineering, right? So then, are there lessons from securing traditional software supply chains that we can uh, adjust, adapt for securing the AI software supply chain? Um, so, couple of uh, responses to what you just said. The first thing, first one is, does anyone use LangChain in production, man? Because it's great for prototyping, but it seems like it's so bloated and so complicated. Because once you know what you're doing, then you don't need all of the extra scaffolding and all the extra stuff that the and then now you have this kind of complicated element of your software supply chain, right? So let's say it's great for, you're exploring, okay, I'm doing this. Okay, so now this is what we're doing. We're going to get data from this, move it here, create a knowledge graph. Then now you can do it yourself. You can kind of do it as for then first advantage is you know it, you can maintain it because you know it well, right? And then it's simpler because you don't have all of the extra things that uh, all these massive frameworks bring. I mean, because you pip install these frameworks, my God, I don't know what they're. Well, I don't. I mean, talk about
Right,
software
right.
supply chain vulnerability. I don't know what they're installing, right? So they
In
they might
enterprise, that
even be uninstalling your version of Pandas and installing an older version. I don't know what they're doing, right? So
yeah, no, it's difficult to be able to get an environment solved, and you see this in Conda also. And yeah, I mean, that's an entire other area of machine learning analysis is just seeing the dependencies that you have to have for your libraries and what's the security impact. Yeah, it becomes like a stack of turtles after a while.
So what about my point, Paco, which is basically use it to explore, and then once you know what you're doing, you can just build all the basic things yourself. I mean, because if
Yeah,
the basic thing is,
yeah.
I'm gonna call an API, I'm gonna do this, I'm gonna do that. I don't need this massive library framework, right?
Yeah, I mean that is an impression. In fact, we were having a discussion. Tomasz and I were kind of discussing something earlier this morning on LinkedIn. Yeah, the dependency bloat for a lot of these libraries, they're great to be able to show all kinds of things you can do. But for a given application, do you need to drag along the other, 30 kinds of use cases? Um, and I think they end up being monoliths, really.
Yeah.
And so you want to think about how can you unbundle this? How can you take certain core parts, make them into a microservice? And I mean, that gets into MLOps side of deployment and how do you manage the crucial parts out in your Kubernetes cluster.
Or how complicated is your pipeline anyway, right? So I mean,
Yeah.
so if you're most of the things you're probably building, the pipeline is not complex, and you can just build it yourself. The advantage being is you know it inside out. And
Yeah, there's a lot of assumptions being made. I mean, this is my criticism of LangChain and Llama Index in general, is that they do try to be sort of one size fits all. We make a lot of assumptions. We do everything. It should really be unbundled. It shouldn't just be a
which
couple libraries. It should be like 30 libraries.
which is fine if I'm just kind of exploring the
Yeah,
convenience, right? So, but
it's
then at some
scaffolding.
point you figure out the sequence of things that you need to do in order to build the app, right? So what are the steps in the app? Then you can, I mean, now I don't have to install this massively bloated thing, which
Yeah.
by the way is installing so many, not only is it installing certain things, it requires versions of libraries you already have. So it's uninstalling the version you have and installing older versions, right? So I don't, I've noticed this with some of these frameworks, Paco.
Yeah, it's tough. I mean, just even like the PyTorch dependencies are tough, or
Yeah.
used to be. They're getting better. There's wheels and all. But I mean, yeah, it's yeah. I do think, especially with RAG, I think the lesson that I've learned is it's not that hard to like build the critical components yourself. LanceDB and others make this really amazing.
Yeah, yeah. This AI software supply chain, I mean, if you're a nefarious actor, all you
Yeah,
need to figure out is one library, right? That
but
that
but
that a lot of people depend on. Boom, right?
but when you go into enterprise, again, a lot of teams in enterprise are going to be using these kind of libraries because they can't afford to hire a large team. And so, yeah, that creates a target.
Yeah, 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 yeah. All right. So my next topic is the AI conference, which
Yeah,
is
awesome.
uh, which is coming up soon. You can find out more at aiconference.com. Um, Paco is going to be hosting. I'll be the program chair, but there's a lot in the program. I'm not gonna go over the entire program, but safe to say this conference is going to be great. It's going to sell out, so you might want to get your ticket soon. And if you want a discount code, go to the episode notes for this podcast, and I'll place a discount code in the episode notes. So, a couple of things I want to highlight. We have a few fantastic fireside chats. The first one is between Robert Nishihara, who is the co-founder and of Anyscale and the co-creator of Ray, along with Mark Chen, who I've had on the podcast. At that point, he was the engineering manager for Dali, but now he is the head of AI Frontiers research at OpenAI. So they will talk about basically the future of AI. So that should be a really good conversation because both of them are in the front lines of implementation, not just research, right? So the other fireside chat is between two luminaries, Peter Norvig and Alfred Spector.
Mhm.
Uh,
Yeah.
I think most of our listeners know these two gentlemen, and they will be talking about what's new and what's next in AI. And then the third fireside chat is with the new Chief Digital and AI Officer of the Pentagon, Dr. Rada Plum, who will be interviewed on stage by Brian Raymond of Unstructured.
Oh,
And
great.
we have a RAG panel moderated by Christy Bergman of Silis, which features
Awesome.
uh, a bunch of people working on RAG, including Prashant Rao of Kusu, who will give the graph RAG perspective with a lot of insights from Paco. Because I heard that you and him have been talking about graph RAG quite a bit. There will be a VC panel moderated by my friend Kenzo with investors from Lightspeed, Khosla Ventures, and IVP, and a startup showdown where
Hmm.
startups will present live on stage, hosted by our friend Roger Chen, with judges Amy Wu of Menlo
Awesome.
Ventures and Thomas Tungus of Theory Ventures. So I
Very good.
barely scratched the surface, but go to aiconference.com for details. Go to the episode notes for this podcast today, exchange.media for your discount code. And on to you, Paco, unless you want to weigh in on the conference.
Oh no, it's great. It's fantastic. I'm going to be in the front row for those fireside discussions, especially Nordic Inspector. Really had a fantastic time last year at the conference, and it'll be even better this year.
All right, on to you.
All right. Do you want to go to like recommendations and
Yeah,
all?
or if you have something quick, I have something quick if you don't have one.
Yeah, yeah. Well, one thing. So real quick, um, a rapid fire topic. There's a new library out called Relic, and it's doing zero-shot relation extraction and entity linking. Just came out. I saw it first over the weekend, and I've been starting to work with this. I think this area where you see like zero-shot models, they're very flexible.
Python, Python.
Yeah, it's
Right.
in Python.
Yeah.
It's using transformers under the hood. There's a lot of benchmarks. But this general category of like Relic and Gliner or Glyrel, a lot of the zero shot work is really adaptable in enterprise
How's
workflows for your
how
domain.
how are the document? How's the documentation? Good.
Pretty good. Yeah, I mean there's an archive paper, there's good docs, the code is nice up on GitHub. Again, this is kind of an emerging category that I've been tracking. A lot of these kind of tools have many applications. Obviously, I work in graphs and they're used a lot for graph construction.
All right. So my rapid fire topic, I point you to a post I just wrote called AI's Mathematical Milestone. So basically, DeepMind built a system that could basically achieve silver medal standard at the International Math Olympiad problems. So pretty impressive. And I tied that back to a previous post I had about machine assisted proofs, where where I
Yeah.
took a look at what machine assisted proofs can tell us about the future of AI apps. But anyway, so it validates a lot of what Paco and I talked about last time. So, all right. So recommendations, quick for me. I think it's a bit off topic, but it's a book called Black Pill: How I Witnessed the Darkest
Oh,
Corners of the Internet Come to Life, Poison Society, and Capture American Politics by Ellie Reeve. It is fantastic. If you want to really learn about I guess, uh, what is it, alt-right, white nationalism, incels, all of these things that have a lot of roots in online culture. Excellent, excellent book. I mean, hard to put down.
um, I'm looking forward to that one. Um, my recommendation, give a shout out to a friend of ours, Claire Sullivan. Recently did a tutorial called When GraphRag Goes Bad. And there's a GitHub repo. Claire posted article up on LinkedIn. But I've been working with her on this, so I can give a shout out. It's about exploring how to use GraphRag, and it's exploring Las Vegas businesses and like PPP fraud. We focus on businesses that are no longer in business, just to be fair. But I think that Claire's done a really great exposition there. It's very accessible and shows a lot of great engineering patterns. So I'll recommend that.
So so are we supposed to take the title literally, which is basically when GraphRag doesn't work?
Well, I mean, I think she's exploring some different areas there. So maybe the title could be more of like, if you were doing RAG, like for instance, just like using, here's my text chunks, and what will be lost when you do a query because the recall, GraphRag tends to enhance your recall, and doing further graph analytics obviously shows you can do even better recall if you leverage the graph parts. So I think that, yeah, the title there might be more about comparing other RAG approaches to using GraphRag.
But basically, top line is she gives you tips about how to make GraphRag work even better.
Yeah, yeah, exactly. And I mean, how to structure your graph actually has some pretty big impact. And she explored that. But this is using open data and it's tutorial. You can grab it on GitHub and run it yourself.
Well, hopefully she used Kusu. All right. And with that, thank you, Paco.
Thank you, Ben.